Welcome all. I am Parthiban Palanichami. From this presentation, I am going to discuss about pressure compounding and difference between the impulsive and reaction turbines. Let's start. Pressure compounding. The pressure compounded impulse turbine is also called as rate AU turbine. After its inventor, this is used to solve the problem of high blade velocity in the single stage impulsive turbine. It consists of alternative rings of nozzles and turbine blades. The nozzles are fitted to the casing and the blades are keyed to the turbine shaft. In this type of compounding, the steam is expended in a number of stages. Instead of just one nozzle in the velocity compounding, it's done by the fixed blades which act as nozzle. The steam expands equally in all rows of fixed blade. The steam coming from the boiler is fed to the first set of fixed blade, the nozzle rings. The steam is partially expanded in the nozzle ring, hence there is a partial decrease in pressure of the incoming steam. That leads to an increase in velocity of the steam. Therefore, the pressure decreases and velocity increases partially in the nozzle. This is the velocity and pressure schematic diagram. If you see the green color, which is denoted that nozzle, it is supplying that steam through the nozzle, where increasing the velocity by decreasing the pressure, and then nozzle will supply the steam into that moving blade, and then again the exit of moving blade steam will enter into that second nozzle entrance, and then the exit of the nozzle of 2 will enter into the second moving blade entrance. Like that way the process is continuing stage by stage. So finally the moving blade started to rotate by applying the torque through the steam force on the moving blade van. Here you can see clearly that the graph is showing the pressure drop. Each and every stage the pressure is reducing during that steam entering and exiting of nozzle into the nozzle. After entering, it is maintaining the constant pressure during the moving blade region, and then again the pressure getting dropped down due to the nozzle provisions. Like that way, this pressure is dropping stage by stage till end of the exit moving blade. As well as the velocity is increased when the pressure will drop down. The velocity increased where the constant pressure also providing that constant velocity of the steam, and then again the velocity will decreasing due to the moving blade. In the case of steam pressure constantly maintained throughout the moving blade region, but that velocity will reduce when the steam enter into the moving blade. In the cycle will be continued till the exit of moving blade. In this way, the velocity and the pressure will role play in this turbine. In the N means nozzle, the figure left hand side showing that N, which means that nozzle. The starting is a entrance, the exit, that small narrow tip is represented as exit of nozzle, and then the exit of the nozzle is connected with the entrance of moving blade or moving van. The moving van connected with the rotating shaft, but the nozzle is supported at the top of the rotor. There is different stages are there according the requirement. Each stage will have nozzle, moving blade according the total number of requirement. Then the steam is also producing the torque towards the rotary shaft. So the moving blade arrow mark represented that movement of the steam. It is trying to applying the force on the moving blade. In the bottom graph, the pressure versus velocity plot is represented that the initial pressure and the initial velocity, and then right hand side outlet velocity and outlet pressure stages. The initial pressure is always higher when it is entering into the nozzle, and that exit of the pressure is stage by stage reduced by dropped that total pressure. But the velocity every stage initially increasing, and then after entering the moving blade it started to drop down. When the dropping the velocity, the pressure maintained at constant level. When the increasing the velocity, the pressure again dropped down at initial stage, which means during the nozzle, the steam flow into the nozzle, the velocity started to increase as well as the pressure will drop down. But the entrance of the during the moving blade, the steam enter with a reduction of velocity with a constant steam pressure. This is major advantages and disadvantages of pressure compounding. Here I am going to give, this is the positive over the set of moving blades as the steam flow over the moving blades. Nearly all its velocity is observed. However, the pressure remains constant during the process. After this, it is passed into the nozzle ring and is again partially expanded. Then it's feed into the next set of moving blade, and this process is repeated until the condenser pressure is reached. It is a 3-stage pressure compounded impulse turbine. Each stage consists of one ring of fixed blades which act as nozzles and one ring of moving blades. As shown in figure, pressure drop takes place in the nozzle and is distributed in many stages. Disadvantages of the pressure compounding. The disadvantage is that since there is pressure drop in the nozzle, it has to be made airtight. They are bigger and bulkier in size. This is pressure velocity compounded. It's a combination of the above two types of compounding. The total pressure drop of the steam is divided into number of stages. Each stage consists of rings of fixed and moving blades. Each set of rings of moving blades is separated by single ring of fixed blades. In each stage there is one ring of fixed blade and 3 to 4 rings of moving blades. Each stage acts as a velocity compounded impulse turbine. The fixed blade act as nozzle. The steam coming from the boiler is passed to the first ring of fixed blades, where it gets partially expanded. This is the schematic diagram of the turbine. Here already we have discussed that fixed blade and moving blade concept. After that we have discussed about nozzle and moving blades. Here we can able to see 3 kind of stages. First one is nozzle. The steam enter into the nozzle and exit into that moving blade. and finally the fixed blades will convey the steam into that moving blade of the second stage. Through in that way the turbine is reacting. Here you can see the pressure versus velocity at initial and outlet of the figure. At the initial stage the pressure is higher, after that it is dropping and maintaining at constant level, and then the velocity it initially increased and then again dropped down and then again increased at the second stage. And this is the overview. The velocity is observed by the following ring of moving blades until it reaches the next ring of fixed blades, and the whole process is repeated once again. This is the basic difference between impulse turbine and reaction turbine. According the pressure drop only in nozzle and not in moving blades. In a fixed blades nozzle as well as in moving blades. Area of blade channels constant in the impulsive turbine. According the reaction turbine vary the blades profile type in the impulse turbine, but the reaction turbine blades aerofoil type. Admission of steam not all round of complete of impulse turbine. The reaction turbine all round or complete. Nozzle fixed diaphragm contains the nozzle, and the reaction turbine fixed blades similar to moving blades attached to the casing serve as nozzles and guide the steam. Power. According the impulse turbine power, not much power can be developed, but the reaction turbine much power can be developed. Space requires less space in the case of impulse turbine compared with reaction turbines. Efficiency of impulse turbine lower compared with reaction turbine. Suitability of impulse turbine small power requirement, but the reaction turbine able to generate medium and higher power. Blade manufacturing is not difficult in the impulse turbine, but in the reaction turbine it's so difficult to prepare the blade. Within this I will conclude the session. I will discuss that